I said everything gonna be alright. I said everything gonna be alright.
Everything's going to be alright. Good day wherever you're listening from, and welcome to Indoor Air Quality Radio, IAQ Radio. It's Friday, February 26, 2016, and it's my loving wife's birthday. Happy birthday, babe. Good. Today's guest is going to be Mr. Jim Newman. Jim is joining us from out of the Detroit area, and of course, on the line from Studio C back in McKees Rocks is the Z-Man, Cliff Zlotnick.
Hello, everybody. Good day, Joe.
Good day, Cliff. And at the controls, we've got John. You gotta have faith. Before we get started with this week's interview, let's thank our sponsors. Let's go there first. And thanks to our newest sponsor, Particles Plus. Particles Plus engineers and manufactures feature-rich particle counters, air quality monitoring instrumentation, and vacuum pump technology. Learn more at www.particlesplus.com. Count on us.
John Don Products, where restoration and abatement contractors shop. Visit them at jondon.com.
CleanFacts, the #1 information source for cleaning and restoration professionals. Check them out at cleanfacts.com.
IAQ.net and Healthy Indoors Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions available at IAQ.net. Please be sure to thank our sponsors for their support of IAQ Radio when you inquire about their products or services.
And last but not least, please visit the IAQ Training Institute website for the most current dates for the training you trust at IAQtraining.com. Let's turn it over to the Z-Man for today's IAQ Radio trivia question.
Win a cool prize by outcompeting fellow IAQ Radio listeners and being the first person to correctly answer the IAQ Radio trivia question each week. Submitting your answer is very easy. Either email it to cslotnick@cs.com, or if you're listening to the show live, you can text in the answer via your computer. Congratulations. To Brian Baker, Custom Vac Limited, Winnipeg, Manitoba, Canada, for the first correct answer to last week's IAQ Radio trivia question. The IAQ Radio trivia question for Friday, February 26, 2016, has been sponsored by Ideas LLC, the solution chemistry company creating unique solutions to odor removal and surface cleaning and decontamination problems. Now for this week's trivia question. What is the most efficient appliance in your kitchen? Back to you, Joe.
Thank you, Cliff, and great to have ideas on board. All right, today's guest is Jim Newman. He's the owner and managing partner of Newman Consulting Group. He's very active in many professional organizations. Cliff and I ran into him. Well, actually, Cliff, I got stuck in the snow and did not get to see his keynote at the recent Indoor Air Quality Association meeting in Orlando, Florida. He's also a trainer for ASHRAE's Energy Standard 90.1 and was one of 16 energy auditors chosen to beta test ASHRAE's Building Energy Quotient. That's a program that measures and categorizes energy use in buildings. He's also the chair of Detroit's BOMA Committee on Sustainability, that's the Building Owners and Managers Association, and is a trainer for BOMA's certification on high-performing buildings. He attended his first indoor air quality seminar way back in 1990, and that was at a BOMA, or no, I'm sorry, it was at the Facility Management Convention in Baltimore. He's an ASHRAE Distinguished Lecturer. He gives seminars internationally on many topics related to construction, including energy conservation, indoor air quality, sustainability, and green buildings. We got some music, I think, for Jim.
It's not that easy being green. having to spend each day the color of the leaves, when I think it could be so much nicer being red, yellow, or gold, or something much more colorful like that.
All right, Jim, it's not easy being green. I've heard you called the Dean of Green. Welcome, Dean of Green. It's good to have you, Jim. Welcome to the show.
Pleasure to be here.
All right, let's talk a little bit about indoor air quality to start with. I know we talked a little before the show, and you started out more on the mechanical side of things, and you've been doing a lot of green building work and indoor, sustainability type work. But let's talk about indoor air quality for a moment. Have you always been aware of indoor air quality as an issue going back to your days early in the Westinghouse days, or is that something you just, picked up a little after that?
No, I've actually been aware of indoor air quality since I was probably about 10 years old because I had a lot of allergies.
Okay.
which were not always, I never thought too much about them being indoor air quality issues. It was mostly, what I'm allergic to outside. But have learned since, and actually that did start when I first graduated from college and went to work, learned that a lot of the indoor air issues are not necessarily from outdoor air, but also from what goes on indoors with volatile organic compounds, off-gassing from all kinds of things, and such as that.
During your presentation at IAQ, I believe you had a slide that, goes back to the early days of indoor air quality. So we know it's not a new issue, but how far back were you able to go and find that people were doing things to, manipulate or manage their building in a way that helped improve the indoor air quality?
Actually, a couple of centuries, because one of my very first slides shows a building that had to be an 18th century building with a large propeller fan on the roof that was the outside air going across it would make it turn. And it was sitting in this building, which of course didn't have any glass windows. They were all open windows. And it would be pulling the air from the lower floors up through the roof that was open at this particular point. So that was causing this cross ventilation, which was cooling people and probably helping the indoor air quality issues that they had then. And the other slide I had was a pot-bellied stove that our great-grandparents, or depending how old you are, who's listening to this, it might be great-great-grandparents, would sit around the country store around the pot-bellied stove and smoke and talk and that sort of thing. And that was definitely an indoor air quality issue, as a lot of fireplaces are today that don't ventilate properly or exhaust properly. So indoor air quality is definitely not a new issue. It just really became a large issue after the Arab oil embargo of '73, when architects tightened up buildings. And we in ASHRAE decided, well, we really don't need 15 CFM per person. Let's cut it way down, because if we reduce the amount of outside air, we'll reduce the amount of heating or cooling we need, and therefore not use as much energy. And that gave rise to all these indoor air quality problems in the late 70s and 80s, well, primarily the 80s, really, because we didn't build all that many buildings in the mid-70s. And the tightening up of the buildings and bringing in less outside air led to what was called sick building syndrome, or building-related illness. And sick building syndrome was probably the most common terminology applied to these buildings, where people would not feel well while they were at work, not because they hated their job, but because there really was something wrong with their buildings, and would feel better when they went home. And it took everybody a while to figure this out, because not everybody goes to the same doctor. So we didn't really, the term indoor air quality or sick building syndrome, actually sick building syndrome came before indoor air quality, and that was probably mid to late 80s. And that that seminar you mentioned that I did in Baltimore for IFMA in 1990, there were very few people in that audience who knew what the three letters IAQ actually stood for, and that's what my entire presentation was all about.
You know, that presentation, you did I'm sorry, I thought you had attended. You had given that presentation. I'll fix that in editing.
I gave that one.
Right.
At that time, there hadn't been any jury trial type lawsuits on IAQ. They came a little bit later.
And that's
and
something
we're going to talk about that.
Yeah,
right?
Absolutely. Cliff, before we do, Cliff, I just want to mention to listeners, and Jim, I'm sure you're aware of this, but the first EPA document that was specific to indoor air quality came out in 1991. That was Building Air Quality, a guide for facility managers and building owners. So you were actually doing presentations a little before that, Jim.
Yeah, actually, and I have that 3-ring binder still, and there's still a lot of good information in it, and I don't know that anybody's really updated that particular binder of IAQ information, but we know a lot more today, certainly, than we knew in 1990, or that even the people in EPA knew in 1990.
That actually morphed into an online program that EPA has called IBeam, the Indoor Air Quality Building Education Assessment Model, I believe is what IBeam stands for. And you're correct. They never, they put out one little addendum to it in a hard copy, but then any other revisions have been web-based revisions since then. So it's an interesting document, and I agree with you wholeheartedly. It had some great, still applicable today information. Cliff, let me turn it over to you.
Okay, let's kind of move along a little bit. What findings of the NIOSH problem building study are notable?
Okay, that was a study that was done several years ago by National Institute of Occupational Safety and Health, and what they found, which one of your speakers a couple of weeks ago was talking about, they found that actually 50% of the problems in problem buildings are caused by the ventilation system, the HVAC system. They found 28% were a specific indoor contaminant, 11% were a specific outdoor contaminant, and 11% they never could figure out. And that's very common with indoor air problems or indoor air quality problems in commercial buildings. It's not like being in an industrial building where something's giving off fumes and you can measure what they are and know they shouldn't be more than so many parts per billion. In a commercial building, it can be very difficult to find what the problem is and where it's coming from.
Okay, let's talk about HVAC systems. Over time, what happens to them and what can be done to prevent it?
Yeah, that's an excellent question. And one of the slides that I use in practically all my presentations, and I do speak about a number of different things, is that what happens to HVAC systems as time passes is that green goes to gray. When you first put in this system, it's working fine. The filters are nice and clean, and hopefully the ductwork is clean. I say hopefully because it isn't always, but especially if the units are run during the winter for some heat or during the summer for some cooling, and they're sanding drywall and not using enough filtration, then the ducts get full of the drywall dust and other things. But what happens is, as soon as you start a system, it starts deteriorating. And the real key is proper operations and maintenance. And we talk about reactive maintenance, which is fix it only when it breaks, which is what, unfortunately, a majority of buildings and organizations do, versus preventive maintenance, which is grease the bearing if it sounds bad, or things like that. And then predictive maintenance, which is the best way to maintain buildings or maintain systems, which is follow the manufacturer's recommendations and do things when they're supposed to be done, even if the bearing doesn't sound bad, for instance, in a fan or a pump. and the manufacturer says if it's a dirty situation, grease it every 3 months, or if it's clean, you can do every 6 months or whatever it might be. That's preventive maintenance, and that saves a tremendous amount of aggravation and a lot of time when you have these breakdown fixes.
You know, Jim, you work a lot with new construction, I gather from talking briefly before the show, and a lot of that nowadays is leadership and energy and environmental design, USGBC type buildings, and some of these newer designs include newer mechanical systems. So maybe things that guys aren't, the old school guys aren't quite used to working on, the maintenance guys. What do you see with respect to helping train those guys that are now going to be operating and maintaining that new equipment in some of these newer buildings you're working with?
That's an excellent question, and we talk about that quite a bit, including not designing control systems that are over the heads of the people who are going to be maintaining the systems or the buildings, and that's done a lot. I mean, we as engineers, we want to give the owner the best bang for their buck. And quite often, we'll give them a system that we know will do a great job for them, but is a little bit too difficult for the operating engineer to understand, and it ends up becoming a manual building. So when we do lead buildings, for instance, the systems have to be commissioned, and what that means is they have to be looked at by a third party to make sure that they're operating properly, and also to make sure that the manufacturer has provided the operating and maintenance instructions to the owner so they know what they're supposed to be doing. Now, the problem there is people typically don't like to read these long operating and maintenance instructions. And if they're not on a disc, but they're in hard copy form and a 3-ring binder, they get put away and nobody ever looks at them again. Sometimes they'll look at them when there's a problem, but typically you just call a service tech who knows how to take care of it, and that's the way it goes. But we're really doing a lot of things with newer equipment that are wonderful. They use less energy. They're easier to operate and maintain, but you still have to know how to do it. And it's so important to have trained people who know how to do that. So it's a matter of working with the manufacturer to make sure the people know that. And in LEED, there's a LEED is a point system, and you get an extra point or two for what's called enhanced commissioning, where the commissioning agent will come back in about 10 months before the warranties run out. And when some people in the maintenance department may have already left or been changed to another department or another building or what have you, and retrain the people that were originally trained. Because we all know that if we're trained on something, the next day we've already probably forgotten 50% of it. In 2 days, it's 90% if you don't review it or start using it right away. And then it's all downhill after a week. So it's operations and maintenance are probably the most important operation in a building after a building gets started. And we do work with a lot of existing buildings too. It's not just new.
And are sometimes these operations and maintenance activities maybe built into the building management system so that it automatically pops up on that guy's computer that, hey, it's time for your 3-month bearing greasing or whatever the case may be?
Yes, there are software algorithms, and there are many organizations out there now that have programs that do exactly this. And what we found is most of them are pretty good, and they don't cost very much. Are many people using them? They've only really been around in good form probably for the last 4 to 5 years. So there are not a lot of companies that are using them yet. But it is the way to go. And this whole Internet of Things that we hear a lot about and read a lot about is going to make a lot of difference in how buildings are maintained, and I think also how well they're maintained in the future.
Here, speaking of maintenance, can you tell our listeners what biofilm is and where in an HVAC system biofilm is likely to be a problem?
Yeah, that's a good one because it's something that most people don't really think about. You know, I don't know if your listening audience is primarily commercial, institutional, industrial buildings or primarily residential. So I'll kind of break this into two parts. In commercial and large buildings, there are these air handling systems that you can open a door and you change the filters out and you look at the coils, and you have larger ones that you can actually walk into. In a residence, you can't really see the evaporator coil that's sitting typically above the fan or in front of or on the discharge side of the fan because it's in a plenum that's all sheet metal with no access door. So you never know how dirty your evaporator coil is. But as far as biofilm is concerned, in an HVAC system, it's primarily on the cooling coil. So what is biofilm? Biofilm is really an aggregate of predominantly bacterial cells that are attached to and growing on a surface. And these bacteria excrete a slimy, sticky substance that allows them to adhere to these surfaces, and it's EPS. It stands for extracellular polymeric substance. It increases the resistance of these bacteria and this biofilm to antimicrobial agents, to heat, to cold, to different cleaners. So it's basically microorganisms and a slimy, sticky substance that sticks to a coil or some other surface. But typically in an HVAC system, the biofilm's on a coil. There are mold spores on filters. There are mold spores all over the place. Some are good, some are bad, and a lot of them people get sick from. But the biofilm is primarily on the surface of the coil. Now, the problem with that is that in mechanical equipment rooms, many times there's a water valve that's connected to a garden hose, that's connected to a typical nozzle on a garden hose, and that's what's used to clean the coil. Well, if you look at a coil and you look at it, there's particulate on the face of it, or maybe even on the back of it too, if it's really dirty. And this, using a garden hose in cold water, typically pushes the particulate further into the coil because most coils in HVAC systems are anywhere from 4 to 8 rows deep. So if you've got a 6-row coil or an 8-row coil, that coil is 10 to 12 inches deep. It's very difficult to clean with just straight water spray. So when you mentioned that I was one of 16 energy auditors working on the beta test of this ASHRAE Building Energy Quotient labeling program for buildings, and while we were at our 750,000 square foot building in Detroit, it just so happened that somebody was down there cleaning coils in that building, and they said, "You guys got to come down there and see this." And we had a 4-man team at that time. We went down and we watched this guy cleaning these 6-row deep chilled water coils with high pressure steam. And I'm thinking to myself, oh, he's got to be bending those fins. High pressure steam, how do you clean a coil with high pressure steam and not bend the fins? The fins are real thin and they're real close together. And this can't be doing a good job. And yet after he was done, it was unreal. I mean, those while they were doing it, we watched the fins, they didn't move at all. And we talked to him afterwards. He said, well, I've been doing this for a long time and I've developed special nozzles and we know how to do it and we don't hurt the fins. And I wouldn't have believed that. But he said, now watch this. He says, we've cleaned the dirt and the particulate off the coil. Now we're going to get rid of the biofilm. And he put something into this boiler that he had that was an environmentally friendly material and started spraying. And what came off those coils was this ugly, black, sticky goo in pieces. That was the biofilm coming off the coils. So if you just clean a coil and get the particulate off of it and don't get rid of the biofilm, it's going to clog up again very, very quickly.
You know, we've lined up, just for listeners, we've lined up a show for later it'll be in late March actually, on this particular topic and some of the new products that are out that help with cleaning coil biofilm. So that's a great teaser for that future show, Jim, and we appreciate that.
Excellent. Well, that's a show that people need to listen to because biofilm is just not thought about enough, and cooling coils aren't looked at enough, or even not necessarily cooling coils, but deep coils like in runaround heat recovery systems where you have a coil in the exhaust and a coil in the supply. We've been on a number of industrial projects that use that type of a system, and those exhaust coils are so dirty that if they're not going to clean them, we tell people, turn them off in the summertime. You're wasting the energy that the pumps have to use to pump the hydronic fluid around through these coils. You're using more energy with the pumps running than you are saving energy in the summertime. Because the energy savings in the summertime are quite a bit less than in the wintertime because the delta T on the coils is so much smaller. So we've done that in some cases.
Jim, how can cleaning efficiency of HVAC components be quantified?
That actually is not the easiest thing in the world to do, but basically what we do is we look at the volume of air going through the coils before they're cleaned and after they're cleaned. We look at the static pressure of the coil before and after, and we look at the temperatures, the dry bulb temperature and the wet bulb temperature coming in, and the dry bulb and wet bulb leaving the coil. The other thing that people very seldom think about, I mean, and those are pretty obvious kinds of things, but what people don't think about is if you clean that coil, the heat transfer efficiency goes back to the coil being practically new. And in a dirty coil, that heat transfer efficiency degrades so much that if you've got a large chiller, for instance, you may have to drop the entering water temperature to the coil to 42 degrees or 40 degrees or something like that rather than 44 or 45 degrees. And for every degree difference, you lose anywhere from 1.5% to 3% in energy. So if you can clean a coil and raise the water temperature entering the coil, leaving the chiller, say 2 degrees or 3 degrees, you've picked up anywhere from 6 to 10% in energy on the chiller itself. So
great point.
Getting people to do this isn't always the easiest thing in the world, however.
Well, but it helps, when you tell people clean your coil because it'll help improve the indoor environment, yeah, that's wonderful. But if you tell them, well, you might also save some money with respect to energy consumption, well, you might get a little more of a positive response. Let's talk a little bit.
And actually, that's not even a might. It's you will save some money.
Exactly. And
right.
Let's talk a little bit about ventilation, Jim. I didn't get to see your presentation because I got stuck up here in the snow, but Cliff had a question here, and I suspect there was a reason behind it because it seems like maybe you have a little different take on what is good ventilation.
Right. Well, ASHRAE actually has a standard that's in many, many building codes in the States called Ventilation Standard for Acceptable Air Quality in Buildings. And it's an ANSI standard, and it's standard 62. We use 62.1 for commercial buildings, 3 stories and up, and we use 62.2 for homes. And the purpose, and I'm going to read this, the purpose of this standard is to specify minimum ventilation rates and other measures intended to provide IAQ that is acceptable to human occupants and that minimizes adverse health effects. And that's what it's all about. But to simplify it, and I talked back in the beginning here when we tightened up buildings and shut down the amount of outside air or reduced the amount of outside air we were handling after the oil embargo of 73, we used to use 15 cubic feet of air per minute per occupant in a building. And we dropped that to about 5 to conserve energy. Well, now we've gotten smarter because of all these sick buildings. We kind of went back to 15 for a while because that seemed to be a very, very good number. But we've changed it because we realized that there's a lot of buildings where there aren't that many people. And if you go 15 CFM per person, you're really not bringing in enough outside air. So now we've dropped that 15 CFM per person to a lower number, like 6 or 7 or 8, depending on what's going on in the building. But it's also a small percentage of air per square foot. So if it's a larger building with not that many people, it might be 7 CFM per person and 0.06 or 0.07 CFM per square foot. And that gives you a goodly amount of outside air to bring in enough outside air in to keep people relatively comfortable and healthy, if it's good outside air.
All right. Well, Jim, what we're going to do is we're going to stop and pay some bills here and thank our sponsors, and we'll be back with the second half of our interview with the Dean of Green, Jim Newman, after about 90 seconds. And thanks to our newest sponsor, Particles Plus. Particles Plus engineers and manufactures feature-rich particle counters, air quality monitoring instrumentation, and vacuum pump technology. Learn more at www.particlesplus.com. Count on us.
The Indoor Air Quality Association, a nonprofit, multidisciplinary organization dedicated to promoting the exchange of indoor environmental information through education and research. Visit them at IAQA.org. Gray Wolf Sensing Solutions. We use advanced sensor software technology and embedded computers to provide superior environmental test instrumentation. Visit them at wolfsense.com.
Legends Environmental Insurance Services, the experts in insurance for environmental consultants and contractors for over 20 years. Check them out at legends-enviro.com.
And of course, our marquee sponsors, John Don Products, where restoration and abatement contractors shop. Visit them at johndon.com.
CleanFacts, the #1 information source for cleaning and restoration professionals. Check them out at cleanfacts.com.
IAQ.net and Healthy Indoors Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions available at IAQ.net. Please be sure to thank our sponsors for their support of IAQ Radio when you inquire about their products or services.
All right, we're back for the second half of our interview. We got Jim Newman calling out of Detroit. Jim, I want to jump right into a little more on mechanical systems, and in this case, the distribution side of things, the air ducts. How important in your mind is the sealing of air ducts, and why is it important? I don't see it happen very often, unfortunately, in most of the buildings I visit, and I'm wondering if you have the same experience.
Yeah, we absolutely do, and sealing ducts is very, very important for a number of reasons. Some of it's indoor air quality reasons, and some of it's the amount of energy that's wasted when ducts leak. And what ASHRAE says is that 75% of ducts, 75%, leak anywhere from 10 to 25%. And typically, because of this, you lose 25 to 40% of your heating and air conditioning energy. And even new systems have duct leakage. And just think about this. Now, let's say you've got a 10,000 CFM air handling unit, and you're leaking 15% into the return air plenum or wherever it might be. You're only delivering 8,500 CFM to the space instead of 10,000. So people aren't going to be as comfortable, and you're going to the heating and cooling is going to have to, the boiler, the chiller, or the rooftop unit is going to have to work harder to keep people relatively comfortable. It's energy conservation, it's indoor air quality, it's comfort. These are the kinds of things that we find when ducts aren't sealed. So, and there are easier ways to do this now, and we talked about that, that you can seal them from the inside. There are now systems out there where you can seal a hole or a space in duct work that's up to 5/8 inches in diameter or 5/8 inches wide from the inside, rather than having to pull down ceilings and rework ductwork or replace ductwork. It's a whole lot less expensive and does a beautiful job. I've seen it work.
Okay, can you tell us a little bit about that system? Is it robotic or what?
No, actually, it's a like an aerosol that goes down the duct and doesn't attach to the duct at all unless there's a hole, because the machine senses the difference between the inside duct pressure and the outside duct pressure. And if there's no difference, the duct is good. And if there's a difference, there's a hole or something in the ductwork that's allowing this differential in pressure. And this material that flows. And by the way, this was developed by the government, Lawrence Berkeley National Lab, I believe it was. I always get PNNL and LBNL confused, but I think it was LBNL that developed this with DOE. And then they put it out for bid, and this particular company right outside of Dayton, Ohio, won the bid, and they've been doing it for a few years now, and it's just made an amazing difference.
Yeah, I think is that Aero? What's the name of the company, Jim?
Yeah, it's AeroSeal.
AeroSeal. Right. Yeah, we haven't talked much about that. We'll have to talk a little bit more about that in the future. It essentially is an aerosol that plugs up that gap. It as it escapes, I guess it starts to build a little bit of a seal there. It's almost I don't want to describe it as a glue, but it's almost like a glue-like product. And I've heard I've heard good things. And Jim, you're confirming that. Let's talk a little bit about some of the IEQ stressors in buildings. What are some of the IEQ stressors?
Okay, IEQ as opposed to IAQ stands for Indoor Environmental Quality, and that takes into account a lot of things other than just IAQ. For instance, lighting. A lot of these new, especially LEDs, and they're wonderful, don't get me wrong, will put a lot of glare on computer screens if they're not installed properly. Or USGBC, we like to have a lot of daylight coming into buildings, and the deeper we can make it go, the better off people are. But again, if you're working on a computer screen and you've got a lot of glare on it, that's not very comfortable for you. And we've even seen people sitting in cubicles where they've got an umbrella behind them to block the sun glare off their computer screen. So this happens. So that's a stressor. Noise, and we think of noise as being too much noise, but there's also not enough noise. I was very concerned with this when we built one of our first buildings that we built for ourselves, for my company. And so I had the rooftop unit manufacturer design and build a super quiet rooftop unit so we wouldn't be able to hear a whole lot of rooftop noise in the building because it was a single-story building. Well, we moved in there, and I realized I'd made a little bit of a mistake because we could hear everything that went on in the office. We could hear a pin drop practically. We could hear the typing. We could hear the people talking, and we ended up putting in ambient noise in the ductwork to block it. So we actually made it too quiet. So you got to be kind of where it should be. The other one is, or another one is vibration. We've been in buildings. We were in a building that was a vibration test lab, and the rooftop unit was right above the test lab instead of being 10 feet over in the corridor. And they had some real problems in that test lab making it work. Then there's the ergonomic stresses, being in a chair that doesn't fit you, or sitting at a computer all day long and not getting up every hour for 5 minutes. And there's also one of the other IEQ stressors that people don't think about too much, but can be a real stressor, would be a psychosocial stressor. For instance, two people in the office don't get along well, and they're always fighting with each other. That's a stressor to them and to other people. Or you come in on a Monday morning and you've just had a bad weekend, haven't slept enough, drank too much, had a fight with your significant other, whatever, and you're just grumpy as heck all day long. And this is what makes up IEQ, indoor environmental quality. Some things we typically don't think about.
That's a good point. Cliff, let me get back to you. I know you had a couple good questions.
Sure, I do. What defensive strategies do you recommend building owners and operators utilize, for risk management reasons?
Okay, that's a great question, and it's very, very important. First of all is avoid potentially offensive building and maintenance material. I mean, just don't use things that are going to be bad for the people applying them or for the people who are inhaling them, like some of these bleaches that are used in bathrooms. And when you go to green cleaning, you don't have these smells, but a lot of people complain, well, our bathroom's not clean. It doesn't smell clean anymore because you haven't used this powerful bleach on it. But one of the bigger ones is to fully commission those mechanical systems prior to occupancy. Because if a system isn't working properly, whether it's the system itself or the controls that are controlling it, people aren't going to be happy. And the other thing is, from defensive strategy, document everything, because here's what happens. When there's an IAQ problem, whether it's a real problem or a perceived problem, and we've been involved with both because we do some environmental work where we're looked to be an advocate. The key is to respond immediately. If somebody complains, you want to respond right away, because that person who's complaining is going to talk to somebody else, and then you might get two people complaining, and 2 goes to 4, and 4 goes to 8 before you know it, and you have what's called mass psychogenic illness. And the real key is that the person who started the complaining, they have the perception that something really is wrong, whether it is or not, but now you've got a whole lot of people thinking there really is something wrong here. So you identify the problem if there really is one, and make the corrections as soon as you can. Those are the real keys, is to respond immediately.
I noticed that's actually the next question we had is, how should the building owner and manager respond when there's an IAQ problem? Whether it is real or perceived. I guess the first thing would be to not assume immediately it's perceived. But, is there anything in addition you would add? Well,
a lot of the things that should be done is building engineers or facility managers should be walking their buildings and looking for things like as if they were somebody from outside going to move into the building or going to buy the building or what have you. And you want to check for sensor stresses, whether they're auditory or visual or olfactory, that people are smelling something, and ask yourself, would I want to work or live here? And periodically check the satisfaction of the occupants. This shows the people who are in the building that you care about how they feel. Are they comfortable? Are they too hot? Are they too cold? When do those things happen? I mean, unfortunately, building engineers have to respond to these I'm too hot, I'm too cold complaints way too much. A lot of it is because people aren't getting enough air, because maybe the ductwork is leaking, or the thermostat in their space isn't calibrated properly, or they don't have enough air in their space, or they have too much air in their space. A facility manager and a building engineer have to be aware of these kinds of things. And if they do walk the building every now and then and ask people, people will know that they care about them. And this makes a lot of difference and actually reduces a lot of the IEQ stressors.
that's a good point. Now, in our show announcement, we talked about some of the legal ramifications, and we've kind of been going into that a little bit here, Jim. And what I'd like to do is spend a little more time on the legal ramifications of indoor air quality problems, and to kind of set that up. I believe earlier you mentioned that, prior to the 90s, or maybe I read this in your presentation, there had been very few lawsuits with respect to indoor air quality. Can you kind of just give listeners a little background on your perspective as to where we were back then and how that may have changed since then?
Sure. Well, in 1990, when I gave that seminar to ISMA, there hadn't been any jury trials in IAQ cases, to the best of my knowledge. By the mid-1990s, that was a totally different story. There were entire floors of attorneys who were salivating over potential IAQ cases, both on the defense side and on the plaintiff side. And some of these attorneys and some of these cases were very good cases. In fact, I think it was EPA in the early 2000s moved into a building, and I'm thinking it was Philadelphia. It's a while back, and they ended up within a year tearing all the carpeting out of their building because there were so many VOCs off-gassing from either the carpeting or the material under the carpeting, or maybe if it was on cement floors, it was the glue that they used to lay the carpeting down. I mean, today, when USGBC started, which was really mid to late 90s, and really started gaining some traction in the early 2000s, there were very few products like paints, like ceiling tiles, carpeting, drapes, chair material that were low VOC or no VOC emitting material. And the early LEED buildings cost a lot more money than the LEED buildings being built today cost, because many of the points are related to indoor air quality and indoor environmental quality, in addition to energy and recycling and those kinds of things. So if you wanted to buy a gallon rather, of low VOC paint, and a gallon of regular paint cost $15 to $18, low VOC paint would have been over $100. So it became kind of pricey to do that, and the early low VOC paints weren't all that good. Today's are terrific. I mean, you can use one coat and really do a heck of a job, and it's low VOC or no VOC. But the potential legal problems, we look at who gets blamed for an IAQ problem. Well, everybody does. The building owner, the architect, the engineer, building contractors, the suppliers, building maintenance people, building management people. The real estate broker might get in there, the landlord, the employers. Depending on who you are and what kind of an attorney you get and how good that attorney is, they could bring in a lot of people into that case. And we've done some expert witness work that's really been absolutely fascinating, kinds of things that opposing attorneys will bring up that have nothing to do with the IAQ problem, but it muddies the waters. So it's much easier not to have litigation than it is to take the time and the effort and the aggravation and the money it costs to be in litigation in an IAQ case. So we tell building owners, you need to do these other things so that you don't get involved in any kind of litigation. Now, we talked about responding right away, but there are times when an owner really needs to seek outside assistance. And those are the kinds of situations where perhaps they can't identify the problem, it's not real obvious. We were called in on one on a building that we had just certified as a LEED Gold existing building several years ago, and they had a condensate overflow from a drain pan and a fan coil unit in the ceiling, and of course it wet some of the ceiling tile, and it wet the wall because it was right near the wall, and they cleaned it up right away. But a week later, somebody started complaining that they just didn't feel well because it was in their area, and so they called us in, and we called in a company that actually does the testing. We don't do that. And they tested everything, and everything was fine. And we wrote a report on it. And they went back to the people who were complaining, showed them the report, but they hopped on it immediately. And that really is very, very key to being successful when there's a perceived or real IAQ problem.
All right, Jim, we're going to go to what we call the roundup. It'll just be me and Cliff, but this kind of gives listeners an idea that we're headed toward the end.
Move 'em on, hit 'em up, hit 'em up, move 'em on, hit 'em up, rawhide. Let 'em out, ride 'em in, let 'em out, cut 'em out, ride 'em in,
Yeah. All right, let's round this up. Cliff, I think I'll go first, if you don't mind on this.
Sure.
I've got one that, in the past, Jim, we've had guests on that were not as positive, let's say, about green buildings and LEED buildings and, implied, if not outright said, that these buildings can have or will have, in many cases, more indoor air quality problems than even some of the older buildings. How would you respond to that? Do you see more litigation with the green buildings as opposed to other buildings, or is it maybe overstated?
Well, I think it's a little of both, actually. When people move into what they think is supposed to be a green building, they have a higher expectation, which they, in truth, should have. Now, here are some of the problems, and I've been involved in some of those discussions. Actually, I'm very aware of people who absolutely hate green buildings, including architects and engineers, but yet most architects think they design relatively green and sustainable buildings. And we have a lot of engineers in ASHRAE who say these are much worse than, like you just said, much worse than older buildings. Well, there's a lot of reasons why they could be, and some of them are that they are bringing in more outside air, perhaps, and the older buildings, people have gotten used to them. They don't have as high an expectation. I mean, we've got a lot of schools, unfortunately, in our Detroit area that have mold on the ceilings and mold on the walls and on and on and on, and people don't like it, but that's the way it is, and you can't have that in what's called a green building or a LEED certified building. And a lot of the things that we do or have done in LEED certified buildings, we want to do the most efficient, energy efficient, the most indoor air quality efficient building that we can do for the owner because they want a green and sustainable building. And quite often we use new systems or new pieces of equipment that don't perform quite as the manufacturer said they might. That doesn't happen all that often, but it does happen. And I know a lot of people will say, well, yeah, I'd like to do that, but I want to be second to be first. I don't want to be the first one using that new system. And I've been involved in some of those new systems, and luckily with manufacturers who really stand behind them and will work very hard to make sure they're working properly and working correctly. But a lot of the new filtration systems, there are many, many claims made with not a whole lot of testing being done. So you have to look for equipment that's been tested, especially filtration equipment, to make sure it really is truly operating the way it's supposed to and not just the manufacturer's claims, and talk to people who've used it. Sometimes what a lot of the complaints about green buildings are is they use more energy than you, Mr. Engineer, said they were going to use. And it's like, well, so we go through our energy modeling and we say, our energy model is fine. How are you using the building? Do you have any people that are now 24/7, because you told us the building was going to be 10 hours a day, 5 days a week, and 8 hours on Saturday, and that makes 58 hours. And we've looked at some of your electric bills, and we agree with you. Our energy model doesn't seem to be working too well, but we're thinking you're running the building differently than what you told us. Maybe they have a tenant that moves in that has data servers, and they didn't expect that. Or there are many, many things that happen in buildings to make a LEED certified building look like it's not doing as well as it could be. Now, from an energy standpoint, a lot of the older buildings might not have as many computers. We use a lot more energy in plug loads, typically in newer buildings, than we're used in older buildings. And plug loads today, even if you've got LED lighting, plug loads today, especially if you've got LED lighting rather, plug loads become a much higher percentage of the total electric load. And there's a lot more stuff plugged into the wall, making up those plug loads today than there was 20 years ago.
All right, Cliff, I've got one other one, but I don't know if you want to jump in here or not. I'm sorry, Jim, I didn't mean to cut you off.
Mine's just more of a comment, and I would like your opinion on it, Jim. You know, to me, the political aspects of green buildings, I find them irritating. You know, those things that don't have anything to do, you know, with energy. The fact that if outside there's a bicycle rack, you know, that you get credit for that. Or, you know, Joe and I interviewed a very interesting guest a couple of years ago, and this guy was, you know, he's in the real estate business. He's made a lot of money. He was really a big believer in, you know, green homes and green buildings. And this guy sought out to build a platinum green home, met all the criteria, and in the end, he didn't get platinum. He got gold because, you know, for political reasons, the house was just too big for him and his family. You know, there was just too many square feet. And, you know, that's my only concern about is the political. And, you know, if you could comment on that, I would appreciate it.
Oh, I love to comment on that, because bicycle racks, we'll talk about commercial buildings and bicycle racks, and I'll get into homes, because we've done 2 LEED platinum homes. And they were not small, but they weren't over 10,000 square feet either. But as far as the bicycle rack argument, it's like, okay, if I'm building a building way out in the boondocks and there's no way that anybody's going to be bicycling to work, then I would agree that getting that point for bicycle rack is not really good. It's an easy point. It's not an expensive point, typically, if you're going to have showers in your building anyway. But if you're building in an urban area and there are people who can bicycle to work rather than driving to work, it's a good point, because we have a lot of buildings with bike racks where people do bike to work and they've got some place to put their bicycles. And it's not just the bike rack. You have to have showers for people to shower in, whether they really shower or not. Typically they don't, because they're only riding their bikes a couple of miles and not working up a big sweat. But that's my comment relative to bike racks. It was really meant to cut down on the greenhouse gas emissions from using other types of mechanical transportation.
What about the size?
The size of what?
The size of the home?
Size of the home. Yeah, I was just going to get to that. Typically, USGBC figures 2,400 square feet for 4 bedrooms. That's really all you should need. And for every 300 square feet more than that, you lose a point. So these 2 homes that we got LEED Platinum on, one was, I think, 6,800 square feet, and one was closer to 8,000. So they started off with negative 20-plus points. And we had to pick up 20 points for them even to get to 0, and yet they got to platinum. And what USGBC says, how can a home be considered sustainable if you're building a 6,000 or 8,000 square foot home for 2 people or 3 people or 4 people? It's not really what we consider sustainable. So we're going to give you, 20 points or so So you're not going to get platinum. Well, these two homes were so good with solar panels and recycled material and on and on and on, and they were both ground source heat pump projects also, that they ended up with platinum. But that's the key point relative to a large size home. USGBC doesn't consider a home that's 2, 3, 4 times as large as it really needs to be. And needs becomes a very personal kind of a thing. If you do a lot of entertaining of large groups and you have an indoor swimming pool in your home, you're not going to build a 2,400 square foot home. You can't. But that's what happened with this fellow that you're talking about. He probably built a very large home and didn't do just quite enough other things to get enough points to be platinum.
According to him, he did and I'm gonna look it up, and I'll actually send you the interview. I mean, it was crazy. This home was in Florida. I remember what they were doing with, they captured all the rainwater. All the stuff was I mean, it was just over. It was just over the top, and money really was not an issue. He could afford to do it, and he tried to do it. And I think that this supposedly might have been the first one, to try to seek platinum, and for one reason or another, he didn't get it. But I'll dig it out, and
I'd like to hear that.
And I'll also put the information on the blog in case any of the listeners are interested in looking for it. So.
Jim,
okay, my guess would be that it's probably over 10,000 square feet, and he probably might have only had 5 or 6 bedrooms. If you've got 14 kids and you build a 10,000 square foot house and you have 18 bedrooms or 20 bedrooms because you have people coming down and visiting, then you could probably get platinum. But if you build 10,000 square feet and you've only got 2 people in the house and maybe, or even 4, and you've got 6 bedrooms and 10,000 square feet, the likelihood of getting platinum is going to be very, very slim.
Jim, let me finish up with one more question. I know we're running a little over. I don't know how quick you can answer this one, but I've always looked at these, some of the green buildings, and I wonder where the trade-off is with respect to the amount of glass and the USGBC wants lighting within the building, which I understand. I think that's important, but when you do that, you trade off energy efficiency as well. I was wondering if you could comment on that a little bit.
Sure. And actually, the new ASHRAE Standard 90.1, which is a standard on energy, says you can't have more than 40% glass in the walls.
In all the walls, or just in?
These floor-to-ceiling windows are going to be a thing of the past. Now, that being said, you don't really need floor-to-ceiling windows in a LEED building to bring a lot of daylight into the building. You have sun louvers on the outside or the inside that can bring the light and the sun further into the building, and the windows don't need to start at the floor. They can start 30 inches above the floor, and people have a very good view of the outside. And this is going to be the new design of buildings in the years to come. There will be very few panel wall glass buildings built in the future. Now, that being said, there are a lot of things happening relative to the R value of glass. And there are windows that are now made that, rather than being in a double glass window, the R value is typically about 3. The resistance value is typically about 3, where you might have 19 in the walls. So it is quite a difference, as you said. But we are getting to the point where there are going to be inside storm windows and even outside windows built that have R values up to 10 and 12 and 13 and maybe even 14 in the not-too-distant future. And, of course, we've got electrochromic glass where you can have the glass shading automatically or manually so that you're not having as much heat come into the building. So there are so many things going on today, it's hard to predict what the way we're going to be building buildings 10 years from now.
I think that's a good point, that it is hard to predict, Jim. And what I'd like to do, and we always do before we go, first, thank you. We really appreciate having you on. Appreciate your openness and willingness to take any question. That's always very. We're happy to see that. Now, the other thing we like to do though is, if there's anything you'd like to add, anything we missed before we go, let's hear what you got.
Okay, the only thing that I'd really like to say is the real key to having a building that is operating most efficiently and relatively sustainably is that the maintenance is actually the most important thing. If you don't have proper maintenance and proper operation of your building, whether it's a building or whether it's a home, actually, I mean, we've gone into homes where people just don't change the filters. They don't think about it. And, eventually their evaporator coil freezes and they have to call a service tech, and the service tech takes a look at their filter and says, well, we really need to look at this about every 3 months and maybe change it once in a while, because they're just not getting enough air over the coil because the filter's so dirty. But proper operations and maintenance is the real key to being comfortable in a building and having the building operate most efficiently. Most efficiently means using the least amount of energy, typically. So that's what I would like to kind of end with, if you will.
Oh, we appreciate that, Jim, and I greatly appreciate you joining us, and hope we can get you back in the future. And next time you speak, I hope I can make it in time to sit in on your presentation.
Well, I would look forward to that. In fact, I'm going to be speaking at the High Performance Building Convention in Fort Worth on May 3rd. So if you happen to be in the Texas area, come on down.
You never know. All right. Well, this is Radio Joe Hughes saying thanks so much to this week's guest, the Dean of Green, Jim Newman. Of course, by the way, next week we've already got Kurt Johnson lined up. Kurt is I think he's the past president of the Maine Indoor Air Quality Council. We're going to talk to him about ventilation. Kurt's a big ventilation guy. We're going to spend a little more time on ventilation next week and talk a little bit about some of the activities that he's been involved with the council. And they have a conference coming up in April that I'll be attending, and we'll be doing a show. I don't know if we'll be live from there or if we'll bring some of their folks on for the show that week, but look forward to talking to Kurt next week. This is Radio Joe saying thanks again to Jim Newman, of course, to my co-host, the Z-Man, Cliff Zlotnick, as always. Great to be with you.
Travel safe to Florida, Joe.
Thank you so much. Of course, to John, you got to have faith at the controls. Another job, no glitches again, John. Looking good. Most importantly, to our growing group of loyal listeners, those downloads are going great again. Thanks, y'all. We'll see you next Friday at noon for the next episode of IAQ Radio.
This has been another IAQ Radio production.